Alright, in this video we will be looking at 11.5, the recursive rules, alright, for sequences. Alright, somewhere on the top of your paper, I know if you were, depending on what class you were in, we had a chance to go over a little bit more than one class than the other. Alright, so somewhere at the top of your paper I wanted you to write a sub n, we know as the rule, right? Alright, and in this section, we're not necessarily looking at just arithmetic or just geometric, but we're looking at terms in terms of another term. Wow, that's 3 terms in one word, in one sentence. But what we want, and I had everyone write this, we want to know, or we need to know that a sub n minus 1, alright, will denote the previous term, alright, which is what we really need to know. Alright, so we'll keep a lot of the questions that you might have in your head while you're going through this will all revert back to, well, knowing what a sub n minus 1 is, alright, and it just means the previous term. So, in this section, in order to find any terms that we're looking for, we need to know the term before it. Alright, so if I'm looking for the 100th term, the 100th term in a sequence, I'm going to need the 99th term in the sequence. Alright, I can't find the 100th term if I don't know the 99th term, and so on. So for instance, if I need to know the 45th term, I wanted to know the 45th term, I need the 44th term, and so on. Alright, so as we quickly look at the example that's on your paper right here, it says write the first 5 terms of the sequence, alright? And in writing the first 5 terms, alright, only way you can have a rule in recursive is if they give you a term. So, well, they give us the first term, they tell us that the first term is equal to 1, alright? And it tells us the term that we're looking for, the rule, or the term we're looking for, is equal to the previous term plus 3. Alright, which means we're going to add 3 every time. Alright, so if you notice, they say, well, the first term is 1, wrote it down, I got to write it down. And then you say, well, okay, the second term is going to be equal to, if we just plug in that n minus 1, this a sub n minus 1 is equal to a1, alright, which is the first term. Alright, so basically we're saying the second term is going to be equal to the first term plus 3. First term is equal to 1, so it's 1 plus 3 is 4, and you keep on going. So if you want to look, if you look right here, alright, you see we say, well, the first term is 1, and then we're going to take the, to find the second term, we're going to take the previous term and add 3 to it to get 4. Then take the previous term and add 3 to it to get 7. Take the previous term, add 7 to it, add 3 to it, get 10. Take the previous term, which is 10, add 3 to it, and you get 13. Alright, and so that's pretty much how we do that. Alright, looking at the one over here, this one's a little bit different, and we don't go into this one as much. Alright, but we want to look at a couple of the problems that are on the bottom of this paper, alright, and see if we can get them done. Alright, so find the first 5 terms of the sequence. So the first problem here is very similar to A, where, okay, they give us a first term, which is 10, and then they tell us, well, the term we're looking for is equal to the previous term minus 2. So we go, well, let's rewrite A1. A1 is 10, all right? A2, the second term is going to be equal to the previous term, which is 10, minus 2, which is equal to 8. And we keep going like that. The third term is going to be equal to the previous term, which was 8, minus 2, which is equal to 6. The fourth term is equal to 6 minus 2, which is 4. And the fifth term is equal to 4 minus 2, which is 2. Alright, and so if we look at this next problem, where I'm just going to cross that out. Alright, that's not for tonight. Alright, if we look at problem number 4, if you want to try to do it, if you want to try to do it, go ahead and try to do it, and then come back or just pause the video and try to do it and see if you do it right. Alright, we're going to keep on going though. Alright, and here it tells us that the first term is equal to 3, and whatever term I'm looking for, I'm going to take the previous term and add 2 to it. All right. So to get the second term, I'm going to take the previous term, which is 3, add 2 to it, and it's going to give me 5. The third term, I'm going to take the second term, which was 5, add 2 to it, get 7. The fourth term, 7 plus 2 is equal to 9. And the fifth term is going to be 9 plus 2, which is 11. All right, keep it going. All right, number 4. Now, in this case, your previous term is here. So the term you're looking for, you're going to take the previous term and multiply it by 2. So we rewrite A1 first. And we say, well, A1 is 1. The second term I'm looking for is going to be 2 times the previous term, all right, which gives us an answer of 2. A3 is going to be 2 times the previous term, which is 2, all right, and that's going to be 4. A4 is going to be 2 times the previous term, which is 8. And A5 is going to be the previous term, 2 times the previous term, which is 16. All right. If you need to go back and look at that again, please go back and look at it. All right, we're going to keep it going though. All right, and so now in this case, they're talking about everything being an arithmetic sequence. All right, everything being an arithmetic sequence. And so if it's an arithmetic sequence, remember to get the term we're looking for, we're going to take the previous term and either add a value or subtract a value. All right, and that by definition is going to give us an arithmetic sequence. All right, so in these cases, number 5, they tell us that the first term is 2 and that the common difference is 4, which means we're going to add 4 every time. From what that's what we learned from 11.2. And they're asking us to write a rule in recursive form. So in order to write a rule in recursive form, we always have to have a term. So we rewrite our term. All right, and if we're adding 4 every time, and we know that because they're telling us that D is equal to 4, we say that the term we're looking for, A sub n, or the rule, is equal to the previous term. How do we denote the previous term? A sub n minus 1. Make sure that's little n minus 1 is small. All right, is called a subscript. All right, and then we're going to add 4 to it. All right, make sure your 4 is like that. All right, and that's all you're doing for this. All right, if we look at number 7, very similar problem. A sub 1 is equal to negative 3. My common difference is 1, meaning I'm adding 1 every time. So if I want to finish writing the rule, and both pieces, you need both pieces to have a rule in recursive. All right, A sub n is equal to A sub n minus 1, which denotes the previous term. I know I'm saying it a lot, but it's the only real new thing in here. All right, and then I'm going to add 1. All right, and so there it is. All right, stop and try. I'm gonna. You can pause the video and try number 6 and number 8. Very similar problem. So go ahead. I'm going to do them real quick. All right, we go A sub A1 is equal to 0, and since D is equal to negative 2, I'm subtracting, so I'm going AN is equal to AN minus 1, or A sub n minus 1, minus 2, like that. All right, and A1 is equal to 12, and A sub n is equal to A sub n minus 1, minus 4. All right, real simple work there. All right, keep it going. All right, these are geometric, meaning we're multiplying. All right, and so for all of these, if you look back, I'm sorry, flipping back and forth. If you look right here, all the problems are set up the same way, where R is the value is just R times A sub n minus 1. All right, so let's see if we can get that done. Hopefully I ain't messed up the, yeah, let's see. All right, excuse me. All right, so we go A1, the first term is equal to 3. And we say the term we're looking for, since R is equal to 8, is going to be equal to 8 times the previous term, whatever the previous term is. That's it. All right, these are really straightforward. A1 is equal to 10 for number 10. All right, and then we say A sub n is equal to, oops, sorry about that, 1/2 times A sub n minus 1. All right, and 11 and 12, same way. So try and pause it real quick, and then try the problems. All right, A1 is equal to -2. A sub n is equal to 0.3 times A sub n minus 1. One way to write it. All right, and then again, A1 is equal to -1. A sub n is equal to -2 times A sub n minus 1, the previous term. All right, keep it going. All right, this is a mix-up of numbers. So there you go. You can pause it, take a look. All right, these problems are a mix of arithmetic and geometric. You just got to figure out what's going on. All right, here it looks like we're multiplying by 2, so r is equal to 2. Here we're adding 12, so d is equal to 12. Here, what's going on? Looks like we're adding 4, so d is equal to 4. And here, positive, negative, so we know it's negative, so r is equal to negative what looks like -3. All right, and we've gone over how to find those common difference values and the common ratio values. From here, let's write our rule. Go back to number 13. A1 is equal to 1, and A sub n is equal to, well, it's r, so we're going to multiply, right? 2 times A sub n minus 1. All right, next one, A1 is equal to 11, and AN is equal to A sub n minus 1 plus 12. All right, here, first term is equal to -12, and A sub n is equal to what? A sub n minus 1 plus 4. Please don't try to combine these. All right, and then the last one, A1, the first term is equal to 1, and then A sub n is equal to -3 times A sub n minus 1. So if you want, take a second to look at some of the problems, it'd be great.